Ayan, can you hear me?
Yes, sir.
All right, fine. Where are the other students?
Neha left for the grandparent thing.
All right, and Anas? Because we are not
Anas
going
left quite a while
anywhere.
back.
We're not going anywhere. Because the point is, we have to finish this topic today because your exams are very close. I hope you're free, right? We'll take 10
Yeah,
more
I am.
minutes. Yeah, 10 more minutes. Okay. This is being recorded, so they will see the recording if they have to, because we are finishing this today. Now, I'm going to show you a video to actually show you a bit about AC current. Just a second. Right. Just a second. Now, can you see the screen, the video?
Yes, sir.
Okay. Now, what's happening is we have a current. No, wait. No. This is a DC motor, not a DC motor. Just a second. Now, can you see the screen?
Yes, sir.
This is an AC generator. Yeah, and now what's happening is we're rotating the coil. Now we are the who is rotating the coil? And the coil is
The
rotating,
magnet.
not the magnet. We are the one who are rotating the coil, right? Because the coil has no power supply. Is that clear? So who is rotating the
Yes,
coil?
sir.
We are.
E.
Now we can't see the person in the video because you don't have to show a person. But if you see over here, you will see there's a stick. Just a second. Do you see that handle over there?
What handle?
The handle at the coil.
Oh, yeah.
Yeah, can you see it?
Yeah.
Can you see my cursor on the screen?
Yeah, now again. It wasn't loading for a second.
Okay, now you can see it. Okay, perfect. Now what is this thing right here? The device right here. That's your ammeter.
Ammeter.
Yeah. Why is there a G over there instead of an A? Because it's called a
That's the unit.
galvanometer.
Oh, okay.
Called a galvanometer. What is a galvanometer? It's used for measuring small currents.
Yes,
is that clear? Write this down. Galvanometer used for measuring small currents.
All right.
When you're done, tell me.
Yeah, I'm done.
All right. Okay. Now let's watch this. If you look here, how is the galvanometer changing? What's happening?
It's measuring the current.
It's measuring the current. How is it changing? Is it going from positive to negative?
Yeah.
It's swinging around. Yeah. It's changing direction.
It's directly correlated to the swinging of the coil.
It's basically it is swinging. The coil is also rotating, and we realize when the coil is literally 90 degrees, the galvanometer shows 0. Yes. Can you see that?
Yes, sir.
It's 90. The coil is 90 degrees right now. It's vertical, not horizontal. When it's vertical, the galvanometer shows 0. Why is that? Now, if you look over here, can you see my drawing on the screen?
Not at the moment. Yeah, now I can.
Now you can. Fine. Now, if you look at this arrow right here, that arrow is your motion. What is it? The motion. Because what's really happening, it's rotating like this, yeah? Like this. It's clockwise.
Yes, sir.
Okay, if it's rotating like that, fine. That's the clockwise. Fine. Just a second. Now what we realize over here is, fine, it's 0. And the field direction is north to south, yes? North to
Yes,
south.
sir.
And the motion are in the same direction. They're parallel to each other.
Yes, sir.
Motion and field. If they're parallel, so that means no current is induced. No current induced. Is that clear? Write this down on your notebook. If motion and
Wait,
field are
sir.
parallel, yeah, tell me.
What what kind of device is used to measure large currents?
Ammeters.
What about galvanometers?
Say that again.
What devices are used to measure large currents?
Ammeters. They're called ammeters, right? So we don't really have something for
And
large currents. For galvanometers are basically for small currents, right?
yeah, but
The large
what's
ones
the
are
small
called
current one?
ammeters. There's nothing specific
Okay.
about that. Okay.
All right.
Now you will find a lot of devices. There's not only ammeter in the world. There's a lot of devices, but you don't have to think about this right now. It will just make things confusing. Okay. Now, so what's important right now is that motion and field are parallel. Okay. So no current is induced. Is that clear? No EMF slash
Yes,
current
sir.
is induced. Have you written this down on your notebook?
Yeah, I have.
You have? Okay, perfect. You need to write this down. I'm going to clear this up. Fine. Okay. If I rotate this again. Now another thing, if you see when it's horizontal like this, it's pointing to the positive direction. Yeah.
Yes, sir.
The galvanometer is pointing to the positive direction. When it goes like this, now it's at the negative direction. Yeah. So look at the handle. The handle is upwards right now. Now look at the handle again. Now the handle is downwards. So whenever the handle is downwards, the galvanometer is pointing to the positive side. Now let's
Indicates
do one
positive.
thing.
Yeah, okay.
Let's call it AB. Let's call this side AB. Let's call this side CD. Can we do that? This is CD, this is AB. Is that clear? Now if this rotates like this, will CD come in the position of AB if it rotates 180 degrees? Will it not? If it goes like this, then these guys will change the direction. Let's see what happens.
Wait,
If
so
I
I have a
rotate
question.
it, ask me, go on.
When the handle is upwards, it's at zero, but when it's downwards, it's towards the positive.
Yes. When the handle is downwards, it's positive, right? Now that's not important. What's important is look at the AB. Where is AB right now? The section of the wire AB. AB is towards the south pole, yeah? And the
Yes,
motion
sir.
at AB is downwards. Yes? The
Yes, sir.
motion is downwards. That's the motion. What is the motion at CD? Upwards? Because the whole thing is rotating like this. So right now CD
Yeah.
is moving upwards. So that's the motion. Okay. Now let's see
Oh,
what
okay.
happens if it rotates a complete 180 degrees. Now where is the handle? Upwards?
Yeah.
Where is the galvanometer?
The negative side.
Negative. So what's really happening is that this CD is no longer here. CD switches place with AB. Now the CD comes over here and AB switches place, right? So it's rotating. First we had AB here,
Yeah.
then CD, then we had AB upwards, then CD downwards. Just a second. Then what happens is CD goes like this. They're rotating like this. It goes up like this, like this. Again, it's going like this, and CD comes here. We have AB here. Any doubts here?
No, sir.
No. Now AB is again going in this direction, yeah? So now what happens is that AB will be downwards and CD will be upwards. Finally, AB will come back to its original position. CD will come back here. Is that clear? Any doubts in this? Any
No,
questions?
sir.
I suppose you're bound to have doubts. That's the whole point. But I hope you're learning something at least. Now let's
I
clear.
understand everything over here.
That's perfect. Good. So let's clear this up for a second. Let's look at the actual demonstration. Okay, we have AB, we have CD. Fine. It's rotating. The whole thing is rotating. Now, AB is at the North Pole right now, but then AB goes to the South Pole. Make sense? Then CD comes, they're switching places with each other. Perfect. So what's really happening is, since the motion on this, the motion on AB is right now is upwards, yeah? So the current is, this is the field, so the current is like this. That's your I, that's your motion, that's your field. Any doubts? The current is towards AB, like
Yes, sir.
this. Now, but what happens if I flip it? Now AB is here. Now what is the motion at AB? Just a second. AB is now here. If AB is there, then the motion on at AB is now downwards. Yes, that's your motion. The
Yes,
field
sir.
is to the right. What is switching? The motion is switching direction. That means the current will also switch direction.
Yes, sir.
Okay. So what's really happening is AB was first. It was first A to B. The current was first A to B. Let's call that positive. But what then happens is it's now going B to A. Let's call that negative. Isn't that happening?
Yes, sir.
Okay, fine. Now let's go back to the whiteboard. Can you see the whiteboard? Just a second. Just a second.
Yeah.
Can you see the whiteboard on the screen?
Not yet.
Not yet. Just a second. Now can you see it?
Yes, sir.
Yes, you can. If you can see this, right now it was A, B, C, D, like this. Okay? A, B to C, D. What really happens is AB is moving upwards first. Okay? Then the current at AB is positive. AB is moving then to the right, in the parallel to the field. So the current is 0. Yes? Make sense? Now AB
Yes, sir.
is now moving downwards. If AB is moving downwards, then the current at AB is now negative. Whatever is moving downwards, that has a negative current. Where CD was moving downwards, so CD was negative. Now AB is moving downwards, so AB is negative. Again, CD is now moving to the right. Both of them are parallel to the field, so 0. Now AB is again moving upwards, so positive. CD is moving downwards, so negative. So what's really happening is they're changing their motion. The motion is switching. Motion is going from upwards to the right, downwards to the left. Isn't that what's happening? This is how it's happening.
Yes, sir.
Upwards, right, downwards to the left. If that's what's happening, the induced current is going from positive to 0 to negative to 0, then to positive again. And this is what the EMF looks like. Can you see this?
Yeah.
It starts at positive, right? Because at the first, AB was moving upwards, so it's positive. This is for AB only. Now then it became 0 at 90 degrees because it's now vertical. It's parallel to field. Again, it's horizontal, but it's at the opposite place. So now it's downwards. It's negative. Again, vertical. So 0. Then up. Over here, it's moving down. Whenever it's down, it's negative. Whenever it's up, it's positive. The motion. We're talking about the motion. Okay. Now, the last thing in this class is that you have to read this. Ayan, read it out.
Okay. Since current is flipping direction at every half turn, y degrees, therefore AC current is induced.
AC. What is AC current? Alternating current.
Yeah.
Alternating current. What is alternating current? It goes from negative to positive. It switches direction. So you can
Yes,
see
sir.
that the current is switching direction. How does it switch direction? Always goes from positive to 0 to negative. Not just positive, negative. No. Positive to it's decreasing, then increasing. That's what's
They
happening.
keep changing.
Keeps changing. Keeps changing. On the other hand, we look at DC in a second in the next class. But can you just recap what did we learn about AC generators?
We learned how they move, how they work, what happens when the coils turn, what like the charge it induces, and I think that's it.
That's it. We get alternating current at the end because the motion is changing. Therefore, the current is also changing. Now, finally, how in the exam you'll have to say how do you know the direction of the current? You know it because of Fleming's right hand rule. We have done this a lot. We have done 10, 20 questions of this. Fleming's right hand rule. So at this AB section of the wire, you just use the Fleming's right hand rule. You know the field, you know the motion, the current will be away. If the motion is downwards, the current is towards, like this. That's it for today. I hope you finish your assignment, have you?
Yeah, I'll submit it by tonight. I'm almost done with chemistry after this.
Almost done with chemistry because see we have to finish a lot of syllabus. I won't be doing this in the next class. I'll share the recording with the other students because we
Yes,
really don't have time for going slow. That's the thing. Okay, take care. Goodbye. One last thing, Ayan,
Bye,
can you
sir.
hear me? Just a thing.
Yeah.
Just a thing.